In physics, mathematics is an integral part in understanding its concepts. In this session, we will be covering measurement in focus. By the end of this lesson, you will be able to compare various measurement systems, align quantities with their respective units, and solve measurement problems. Measurement in focus has played an essential role throughout the history of time. They may come in different forms and measuring means, but it is obvious how useful it is. During the ancient civilization, it was believed that people used part of their body in measuring physical quantities. People have become accustomed with it. However, as modernization took its ground, measurement needed to have a standard. Measurement is a process of comparing something with the standard. There are two measurement standards that are still in use today. The most common systems are MKS system or meter, kilogram, and second, and CGS system of measurement or centimeter, gram, and seconds, which are under the metric system. While the FPS system or the English system of measure remains to be useful in many cases, metric system is a measurement system agreed by the General Conference of Weight and Measures as a modern form of measurement. It is the International System of Units or SI used in majority of the world. The things we measure come in two identities: fundamental or basic quantities and derived quantities. Fundamental quantities are independent measures. These physical quantities can be arranged in the following: length, where its unit under KMS system or SI unit is in meters, mass in kilograms, time in seconds, temperature in Kelvin, current in ampere, light in candela, and substance in mole. The corresponding units mentioned may be different in various measurement systems, as base units refer to the units of corresponding fundamental quantities. On the other hand, derived quantities are a combination of fundamental quantities, for example, velocity, acceleration, force, density, and many others. Sometimes, these values for measurement would come too small or too short to be written in a practical and understandable sense. This is where scientific notation proves its importance. Essentially, this is writing each number as a decimal with only one digit to the left, or the decimal point multiplied by 10 raised to a power. For example, the speed of light in a vacuum is about 300 million meters per second. You may express it as 3 followed by 8 zeros, or simply by writing it as just a 3.0 multiplied by 10 raised to 8 in scientific notation. How about writing small numbers? The size of a bacteria is about 5/10,000 of a meter. Alternatively, you may express it as 0.0005 meters, but to make life easy, it is either you convert it to smaller unit or express it in scientific notation. That's 5.0 multiplied by 10 raised to -4 meters. As you may have noticed, when you move a decimal point to the left, that's for large numbers, the exponent will be positive. While moving the decimal point to the right, for smaller numbers, the exponent will be negative. An alternative way of expressing values in a simpler manner, as mentioned, can also be by conversion from one unit to another. We'll check that one out in a separate video. For now, we learned about the comparison of various measurement systems, alignment of quantities with their respective units, and solving measurement problems. Let's check what we learned. Try to answer the following items. How do you think people from the past measured length, weight, and time? What are the base units for FPS system or the English system? And finally, using the scientific notation, what is the diameter of the Sun if it's 1,391,400 kilometers? The perception of the world differs from person to person. Deviation of ideas, conflicts, and/or norms are ways of looking at new angle and perspective. Sometimes, there is neither right nor wrong between two arguments. We should always try to be open and willing to accept differences or opinions from time to time. Thanks for watching. See you again on the next one.